This is my implementation, or this is my kata of converting Arabic numbers to Roman numerals. We're going to start by creating a test class, because we always want tests first. And I'm just going to put all of the assertions in one test, because it's such a small problem. It's going to be a too heavy weight to put them into separate tests. We're going to call the function Roman from, so that you read, or actually we'll call it get Roman from, so that it'll read get. So that it'll read get Roman from and then a number. So get Roman from 0. It'll be more intuitive that way. So let's go ahead and run the tests, and we see that we need to create the method. And we want to have this be called Arabic, and we don't really need anything until we have an assertion. So let's put an assertion. Now, 0 is not a case that's defined in Roman numerals, so we'll just call that the empty string. And the next natural case is 1. We'll just stick with that for now. We're going to venture away from what people usually prefer to do on later tests. Venture away from the normal order later, but for this one we just want 1, and that's a pretty easy one to get passing. And I got it backwards. There we go. So then what we do next is not 2, as a lot of people like to do, and what seems natural. 5 is actually a little easier to handle next, because it's just changing the character that we're returning. It'll lend itself well to refactoring that we're going to do in a minute. A lot of times you want to think about what will make the simplest change to the code, and you should do tests that you should choose tests that will change the code in small ways as opposed to large ones. So in this case, we can just we can say return. This will get us passing quickly, but what we really want is we want to have a dictionary lookup. That's what I'm seeing here, because it's kind of silly to have this cascading check like this. So let's go ahead and call the dictionary conversions, and we'll put the shape of the code in before we pass any functionality to it. Alright, so now that we have the shape, we can start passing functionality. And that means I can delete that line, and let's make sure that worked. And then we'll do the one case. We'll leave the empty string there as a fall through, so that it's clear that it's a default case, not just what we do when we hit 0. Now I could go ahead and start implementing all of the numbers, all the major digits, so like 10, 50, etc. But that's not really going to be interesting. It's just going to be adding things to this conversions hash. So it's good to have your test teach you something about the code when you write it, when you make that test pass. So one that's going to get us teach us a little bit more about what the shape of the algorithm should be is the 2 case. Now, it's easy to get this passing given our current structure, but this really isn't going to this really doesn't work as a sustainable large-scale solution. And there's actually some subtle duplication here. What we really have is this situation. So why don't we make a case to help that stand apart? And this won't be touched by the code yet because the conversions hash will get in the way. And I'm gonna get rid of the demonstration code that I just introduced. And let's go ahead and make sure that works, and that works. So now that this works, I can break apart the logic. And what we can do is, what this really is, we can go ahead and look up in the conversions hash the values for each of these, which is in both cases 1. And this is starting to feel a little awkward. Let's go ahead and let's figure out what. Let's get another case to teach us a bit more about this new construct we've introduced. 3 is basically the same, but with one more I. So that's going to be good for helping us figure out this algorithm. And it's actually pretty easy to get this working. All right. So now we've gotten this bit of functionality working on the 2 and the 3 case. And I want you to notice now that there's actually some duplication. The information in the conversions hash is not entirely necessary in the 1's case. So let's try to eliminate that from the conversions hash dictionary. Sorry, you can tell I learned Perl before Python. So now we're not dependent on the conversions dictionary at all. So let's go ahead and change the condition a little bit. And now I think we can remove this. And yes, we've simplified our code slightly. Now, it looks to me like this conversions dictionary is not the right algorithm. And so I want to introduce some sort of piece of code, some sort of test that will help me eliminate this part as well. So in order to do that, I'm going to do 6, because that requires me to draw out a 5 from the code and draw out a 5 from the code. So obviously that fails, just like we want. And once again, this is not really an ideal solution. So let's do this. And I'll pull this out of the dictionary. Now, I could go ahead and add another test for 7 and do the same thing we did with 2 and 3, but I think that it will simplify the code to just refactor at this point. So first of all, let's take this observation here. And then we can say that instead of doing 1 directly, we could do get Roman from Arabic -5. And now let's go ahead and change this to a 5 to cover both the 5 and the 6 case. And I can kill this bit here. And now we can get rid of this dictionary altogether. This is fairly common in test-driven development. Your refactorings from earlier end up being completely backed out when you discover a more appropriate algorithm. And now we actually have, we've eliminated the duplication from the conversions dictionary, but the shape of these two conditions is very similar. So let's go ahead and have a new condition to handle this. So we have, I'm going to introduce a list called conversion factors, because we are not just doing a lookup, we're iteratively checking smaller and smaller numbers now. So then it's going to be a list of tuples. So what we're going to do is have it be the Arabic factor followed by the Roman factor. And as I've done before, I'm building the shape of the algorithm before actually introducing anything, before handing functionality over. And let's go ahead and test it at this point. So then the Arabic factor we want to do first is 5 and 5. And you'll notice I've not replaced the variables. We'll do that while we have the ability to run tests after each one, so that we can make these changes safely. Alright, so we've handed that functionality over, and let's go ahead and test hand the one case over as well. And now we can delete these two lines. And at this point, we've actually gotten the shape of the algorithm. You might think that I want to do something special with 4, but I would assert to you that it's much clearer in the code to have 4 stand apart as a separate case. So by letting 4 stand apart, it's just clear what happens on this corner case. So from here on out, it's data entry, and I'll do a little bit of, I'll go up to 20, just to give you an idea of where how this code will grow. But I don't think more than 20 is we really need to worry about for the purposes of this kata. And this one should just pass immediately. And it does. Okay, well, thank you for listening. This has been a fairly interesting kata. What I found most interesting about it is the way that we built up a dictionary first, and then after the dictionary got built up, we tore it down and ended up replacing it with an entirely different data structure. And going through that in small steps using refactorings is a pretty useful exercise, and it's a skill that I think everybody should develop. Because when you go through these refactorings in small steps, it's very easy to tell if you make a mistake in the refactoring where it happens.